Well, hello there. We're going to continue with inequalities, and today it's all about solving one-step inequalities. So make sure you have your composition book and your foldable ready to start doing the examples inside. So let's start with example 1. When we're talking about inequalities, we solve them the same way we do equations. So therefore, in this example, the inequality symbol separates the two sides. When we look here, we have plus 9. Since there is plus 9, that means in order to get x by itself, we're going to have to subtract 9 from both sides. When we subtract 9 from both sides, we're left with x is less than 6. That means that any number that is less than 6 will make this a true statement. So you could pick any number that is less than 6. I'm just going to pick -1. If we plug in -1 for x, okay, and we say -1 plus 9 is less than 15. -1 plus 9 gives us 8. Is 8 less than 15? Yes, it is. That means that any number less than 6 will make this a true statement, that x plus 9 is less than 15. So when we're solving inequalities, we're getting solutions. There's more than one solution when you're talking about an inequality. Now look at example 2. We have x minus 3 is greater than or equal to -6. Separate our two sides. Again, the goal is to get x by itself. The way to get x by itself when we have x minus 3 is that we have to add 3 to both sides. So now when we add 3 to both sides, we have x is greater than or equal to -6 plus 3 would give us -3. When you have that equal to, that means that -3 will make this a true statement, as well as any number that is greater than -3. So if we were to graph that on our number line, we would have, and we would put a filled in circle because it can equal -3, and it says that x is greater than, so we shade everything to the right. Example 3. We are talking about a one-step equation again, inequality, and we've separated the two sides. The operation that is going on between 3 and x is multiplication. Anytime you have a number next to a variable, it's always multiplication that's going on. So if we want to get x by itself, since that's multiplication, we have to divide by 3. Whatever we do to one side, we do to the other side. So now we have x is less than or equal to a -27 divided by a +3 gives us a -9. And here again, this means that -9 will make this a true statement, because if we plugged in -9 for x, 3 times -9 would give us -27. And so here, -27 is less than, or it could be equal to, -27. And then any number that is less than -9 could also be put in for x for our multiple solutions. So if we're going to graph that on a number line, we have a filled in circle, and it said that x is less than -9, so we go and fill in everything to the left. Now example 4, I'm going to separate the two sides of our inequality. When we look over here on the side with the variable, what operation is going on between x and 7? It is division. Since that is division, we have to do the opposite, which would be multiplication. So therefore we have to multiply both sides of the equation by 7 so we can get x by itself. This is the same thing as 7 over 1. The 7's will cross reduce and equal 1. Now we're left with x is less than negative 3 times 7 gives us negative 21. That means we could put any number in for x that is less than negative 21, and it would be a true statement. If we're going to graph our solution, we'll make our number line. And since it is only less than, we have an open circle, and x is less than, so we have to shade everything less than. Now let's look at example 5. Again, I'm going to separate the two sides with a line. And here is where inequalities are a little bit different than equations. When we look at the side of our inequality that has our variable, we see that negative 8 and x are being multiplied by each other. So therefore, we have to do the opposite, which is division. And so we divide by a negative 8. Now, I told you that this is different than equations because anytime you divide both sides by a negative number, you must flip your inequality symbol. So now it goes from greater than to less than. Negative 8 divided by negative 8 gives us x, and 40 divided by negative 8 gives us negative 5. Okay, so this is saying that if we put any number that is less than negative 5 in for x, it's going to be a true statement. And you say, well, why did we flip it? Okay, if we had left it as x is greater than negative 5, okay, so let's pick a number greater than negative 5. How about we pick 1, okay? If we plug in 1 for x, negative 8 times 1, and we still leave it as the greater than, and then we have 40 over here, negative 8 is greater than 40. Is that true? No, it's not. Okay? That's why we have to flip the inequality symbol, because otherwise, when you're dividing by a negative, it changes the sign. And so if you change the sign on one side, you have to change the sign on the other side. And so that's why we flip that inequality symbol. And so now if we were to graph our solution, make our number line, we have an open circle above negative 5, and x is less than negative 5, so we shade everything to the left. Alright, here is our last example. Separate the two sides. We look over here on the side that has our variable, and we see that x is being divided by negative 4. Since that's division, we have to do the opposite, which is multiplication. So we are going to multiply both sides by a negative 4. And again, when we multiply both sides by a negative, we have to flip the inequality symbol. It's only when we're multiplying or dividing by a negative, not when we add or subtract. Okay, so now we're left with x is less than or equal to 36. And then if we graph our solutions, it said that x can be equal to, so we put in a filled-in circle, and that x is less than, so we shade everything to the left. You'll notice in your foldable that at the bottom there is a box that says Don't Forget. This is what you need to be writing in that Don't Forget box. You must flip the inequality symbol when multiplying or dividing both sides by a negative number. And that's the big difference between solving inequalities and solving equations. So we're going to practice this in class. So hope you've learned something, and we'll talk about it more in class.